welcome to Hardcore PKI 2020. So, my name is Tomas Gustavsson. I'm the CTO and co-founder of PrimeKey, and I've been a PKI geek since the mid-90s somewhere. About 100 years ago, not really, but almost 20 at least, I founded the DGBCA open source project, and I do get a lot of questions around PKI, which is why I'm here today, of course. The short agenda of today is I will go through the, say, high-level topics of Hardcore PKI 2020 and then dive into the details. For those of you who haven't seen Hardcore PKI before, it's been a recurring theme of the PrimeKey Tech Days that we have had for several years. And the idea is that I go through a couple of topics that I personally have found hardcore for me or for the things we have been working on during the past year. So, without further ado, the topics I have chosen for this year is a few topics that come to the top of my head. So, and the first one is that sometimes the standards don't really do or doesn't exactly have what you want them to have. So there are a couple of things that you want to do to adapt to it, but it becomes hardcore when tweaking is done of the standard in a way that existing clients and code interpret it. And I will exemplify this by tweaking standards, some details. The second topic is kind of referred to not invented here syndrome. And this happens when user communities are a long way from each other, deliberately or not. I mean, normally not deliberately, so there's no bad intent here, but it happens with different user communities. And the result is that similar use cases are solved in technically very different ways. I will exemplify this by the proliferation of CA types we have seen in recent years. And the last topic is that complex problems usually are also solved by complex technical solutions. And usually there is a reason for things being complex and then the solution being complex, but the things may lead to glitches a couple of years down the road. I will exemplify this by trust or specifically cross-certification and bridge certification. So, moving into the first topic about tweaking standards. So everyone thinks that interoperability is important, but sometimes the standard doesn't exactly do out of the box what you need it to do for a specific use case, mostly for legitimate reasons. The standard maybe was developed 10 years ago while your use case wasn't even thought about. And of course, standards are usually developed kind of in a broad sense in order to encompass future use cases. So usually we have two tools to fix this, so to say. And one is that we profile the standard, which means that we either take the standard and limit the set of features we use for the standard to enable better interoperability, or we take the existing fields in the standard and specify how they should be used in our specific use case. The second tool is certificate extensions. So X509 have extensions, but a lot of other certificate formats also have extensions. So we can add things that help our use case, which wasn't thought about when the standard was developed. What makes it hardcore is when you tweak standard, or you can say take a shortcut and tweak the standard in a way that is not intended in the standard, or makes things, or that existing clients interpret differently. So maybe you add a new meaning to existing functionality in the standard. I will detail this with a real-world use case in the details part of the presentation. Back in the good old days, when me and Admir started in this business, there was just one type of certificates, X509. It was V1 from the beginning, and later came V3 for good reasons, though. In the recent years, though, there has been an explosion, I would say, in different certificate types, and more are definitely coming. So I'm not being so bold as to say which certificate types are really needed and which are not, but many could certainly have reused a standard that was already out there. And the thing is, of course, that large organizations will need several of these standards, and we are being asked to support several of the standards. And then many times it's hard to justify the cost of implementing, maintaining, and supporting these custom formats unless the user base is large enough to kind of support the cost and personnel base that is needed to support it for long term with quality. And of course, not to mention that when there's a new standard, there are usually new security issues that pops up when being analyzed. I will give some examples in the details section, of course, but you definitely have to think about the cost versus benefit when you define a new type of certificate. The last topic I chose is trust. So how can we make trust work? Trust in a complex world is, of course, just complex. There's no doubt about it. And over the years, there have been different attempts to solve trust issues in large distributed organizations, such as governments and very large organizations. For the web PKI, or what's also referred to as public trust PKI, cross-certification is very commonly used. Usually only one way, but still we consider it cross-certification. And another example is the US Federal Bridge, which uses another approach, which is a bridge CA. The US Federal Bridge in particular have a lot of information public, which makes it a very good educational material. And well, in common with this method is that they enable trust between different organizations without having to do root CA exchange, which would be in comparison to, say, ICAO PKI, which is used for electronic passports, where a diplomatic exchange is needed in order to help or to establish trust between two countries. We typically don't want that in when we need to make things a bit more efficient. Well, what makes this hardcore is that when using these kind of simple non-simple hierarchies, things grow over time, people come and go, organizations are acquired and merged, departments are dismantled and new ones are put in their place. And this makes the trust relationships hard to manage. So it's not obviously visible in software or in monitoring systems what the trust relationships are. And it also becomes hard to implement in software, which we will see in a practical example in the details section. So this relates to a quote I like, which is attributed to Einstein, but not 100% sure it was him anyway, that everything should be made as simple as possible, but no simpler. We'll get back to that. So, on to the details section. This is what you all came here for, I think. For the first topic about tweaking standards, I exemplified this with what has been come to be called the curious case of the dangerous delegated responder certificate. This topic was extensively discussed in Mozilla Development Security Policy mailing list over the last couple of months. There are references in the last slides for those who download the slides and want to read more details. Anyhow, the core of the issue is extended key usage, which is a certificate extension, as defined in RFC 5280. It defines extended key usage as something that typically occurs in end entity certificates, and specifically it defines the extended key usage defines what the public key in the certificate the extended key usage extension occurs in should be used for. For example, SMIME or client authentication or server authentication. On top of that, the CAB forum baseline requirements defines something called a technically constrained subordinate CA certificate, where they specify a usage of extended key usage extension, which is maybe not exactly in line with RFC 5280. And as the result, client implementations are different. So there are a lot of clients parsing certificates out there, and clients from big organizations like Microsoft, Google, Mozilla, OpenSSL, other libraries, etc., have, it has become a little bit of confusion among CAs, implementers, and pretty much everyone how to exactly implement and interpret this. So Mozilla, being an open source project, have maybe the best public documentation of a suggested way to implement this logic. But standard specifications should not have to be in a product source code, hopefully. And it makes me wonder if it's possible to be compliant with RFC 5280 and the baseline requirements at the same time. To be fair, the baseline requirements don't specify that you must be compliant with RFC 5280 as far as I can find, but usually you want to be that. And maybe on the downside of RFC 5280, they haven't specified this particular topic with enough detail on must and must not, which actually gave an opportunity for this thing. Why is tweaking standards hardcore or a high risk? So one thing is that implementers read RFCs, and commonly the standard tweak is not as widely publicized as the RFC for sure, and probably not specified in detail enough either. So when people implement software, they will read the standard and interpret them, so it's hard enough to interpret RFCs, and then claim for compliance with RFC 5280, for example, with limitations, always limitations. And that leads to the tweak will not get implemented correctly or as intended in different implementations. Some implementations will have the tweak and others will not. And over the years, your use case will pass across many different implementations and then break in some and work in some. Because no software toolkit or library works forever. You will want to use new technology like Java 47, Go, Node.js, Rust, new future languages that we don't know of today. And these new technologies may not have the correct tweak. So my kind of completely arbitrary prediction is that if you tweak RFC 5280, there's a 50% chance that you will end up in some sort of problems, interoperability issues or outages within 5 years. Of course, 50% is taken out of completely nowhere, but just consider if there is a risk of this, if it's a risk worth taking. Moving on to the second topic about the proliferation of CA types. So here is a simple list of different certificate types that we have been asked for over the years. I already noticed that I forgot one, attribute certificates. The same can, by the way, be said about digital signature formats for documents and code, where there are also kind of a proliferation of different ones. That would be the topic of another talk. Anyhow, so as the bold ones in this slide, we have implemented, it's 3 or 4, depending on how you count on it. EAC 2.10 builds upon EAC 1.11, so you can consider them the same or separate, if you like. Some other formats we have offered, usually for a cost, to implement to customers asking for it, but it wasn't attractive enough either for the customer or us to warrant the cost of maintenance. We have definitely estimate that we will support more formats within a year or two, but it has to be carefully selected because, as I mentioned before, there is a cost to maintain something new like this over a long period of time with quality. If you have other examples of certificate formats, please let me know so we can fill my list. And I would just urge everyone here when implementing new formats or trying to devise new formats to try to use existing formats and proven standards if they exist. The last topic, cross and bridge certification. So I'm not here to bash the federal bridge or web PKI if you're using cross certification or bridge CAs. So actually it may just, in fact, be as simple as possible, but not simpler. I'm not the one to judge that. I just want to highlight some hardcore issues that arise to remind us all what these complexities can lead to. There's also some references in the last slide for later reading if you want as well. So cross-certification is something that has been around as a theoretical concept for a long time. It's, I would argue, quite rarely used in practice, which is due to the trust complexity it involves. But it's very commonly used in the web PKI in order to, have long-lived CAs being trusted and adding new CAs, etc., across an internet scale of different clients. So there's a good reason for them to use it. So the hardcore example here, though, is something that happened this year, which involved the add trust root CA expired, which was a very old root originating from Sweden, believe it or not. But the current owner of this root actually had everything in place technically, so no shadow on them. In theory, everything was done properly and nothing bad should happen. But these CAs are so widely deployed across such a large set of different relying parties and software implementations. And sometimes there's bugs in path building in the clients. In some clients or implementations just have simple, you can say naive implementations, not considering the possible complexities of these trust forests. And some actually handled it perfectly well. But the result was that there were some kind of pretty large and spectacular outages on internet services due to this root CA expiration. The second example, which I don't have a real reference for, is that when using, well, particularly I heard this related to bridge CAs, where a bridge CA is a great concept then to enable kind of trust between organizations that don't have to meet, etc. But what also happens is that you put a lot of trust in other organizations that you don't know about through the bridge CA. So what supposedly has happened is that in one organization, by a mistake, added a test CA into the production network, which actually made all the other organizations trust their test CA, which obviously didn't have the proper security controls in place. But this shows the possible dangers of this complexity when one mistake by someone actually affects on you. So what can we do, so to say? As I mentioned, it's a complex world, so we definitely we will not be able to prevent outages or bad things happening. So this is just a bit of funny thing for my last slide. In EGBCA, we have a feature to not expire on these weekdays. So you can set, when you create a new CA or server certificate for that matter, to set them to always expire, is in this example, on Wednesday or Tuesdays, to at least keep the weekends free. So when shit hits the fan, you at least don't have to be called in on the weekend to do the cleaning up. So this is a small thing, but small things can help you a lot. So when designing trust, think about the long term. Perhaps it is as simple as possible, perhaps it's not. So just think one extra round. Some references for those who want to check more details later. Otherwise, I say thank you for watching Hardcore PKI 2020.